Alright, good morning, geometry students. Today we are going to be doing 7-7, and yep, we skipped 7-6, so it goes 7-5 and then 7-7. And today we are going to be doing scale models and drawings. Scale drawings and models. Doesn't really matter which way we go, I guess. So a drawing is just that two-dimensional space. We're drawing it on paper. Where a model would be something that we're like doing it in 3D. We're making it like out of Legos, or we're building it to be the actual like model of something. Okay. So a scale drawing or a model is a way to show something accurately. So to show something accurately that is much bigger or much smaller using proportions. That's my computer, FYI. Are much smaller using proportions. So an example of a scale drawing would be like maps. So when you look at a map and you're looking how to get from this town to that town, they really shrunk it down so that you can see it all in one picture or in one screen. I don't know if you're looking at it on your phone. Okay. So that would be something that is much bigger, that's scaled down, or we could talk about like the Empire State Building. If you wanted to build that out of Legos, you wouldn't actually build something as big as the Empire State Building, okay? But it can go the other way, where it's something that's much smaller. So like when I was in high school, I had to build a replica of, I think, of the mitochondria, and I made it much bigger because we can't really see mitochondria without a microscope. So I made it bigger so you can break it down, look at the different parts of it. Okay, so as we go today, we have a couple other important words. We have a scale. Okay. And scale is a ratio of measurements. So it's just our ratio, how we compare. In this one, we do use the colon, the two dots. And we always go with the drawing or the model compared to the real life. So that's just always the way our scale goes, so that our readers, everyone who's working with the scale drawing or the scale model, will know that it's always the drawing or the model compared to real life. So it could also be the model compared to real life. Okay, and then our last one, we actually talked about this back in 7-1, but we haven't really talked about it at all, is the scale factor. And scale factor is a ratio of the measurements, or the scale, in the same units. So using feet in feet, or miles in miles, or inches in inches, versus doing like 3 inches to 2 miles. Okay. Alright, we're going to do 2 examples today. We're going to talk about a toy plane that is 4 inches long. And the actual plane that it's based off of is 38 feet long. Right, so we want to find the scale and we want to find the scale factor, which we'll do after we find the scale. So for the scale, we want it to be from the model to the real life thing. So our model, we have 4 inches compared to our actual plane is 38 feet. However, we want to simplify this. And we can think about it as like a fraction. What can we divide both 4 and 38 by? I know they're both even numbers, so we could divide them both by 2. Or we could use Desmos, which I didn't have open yet, so give me a second. Okay, and we can put it in as a fraction 4 over 38, and then hit that little fraction button over on the side here, and 2 over 19. Okay, so really our scale is 2 inches for every 19 feet. So we know every time that 2 inches, it's 19 feet across or long. So we know that that's how long the plane is, but we could measure like the wingspan. How long is it from the wingspan, and we should be able to guess how long is it in real life. Well, not guess, we should be able to know, really. Okay, but if we do a scale factor, our scale factor, we want it to be in the same units. All right, in this case, it's probably easier to change 38 feet into inches. So I want to know how many feet, or how many inches is 38 feet. Okay, and we want to remember that 1 foot equals 12 inches. That's going to be something you'll use a couple times today. So if you need to box that, just remind yourself. Okay, we could definitely probably just ask Siri how many inches is 38 feet. Or we can just do 38 times 12. So 38 times 12. And we get 456. So we know that that plane is 456 inches long. So again, for our scale, we're still going to compare our model to our real life. So our model is only 4 inches to our plane, which is 456. We can put inches on the side because we know they're both measured in inches. Okay, and again, we want to simplify that. So 4 over 456. Hit that fraction button at the end. We get 1 to 114. And that is our scale model, or scale factor. All right, we have one more problem to do. Number 2. Okay, a map has a scale of 1 inches to 20 miles. Okay. A road on the map is 9 inches long. How many miles? How long is the road in miles? Okay, and this one, most people can, not most, some people can probably do this one in their head because we have our scale factor as a 1 to 20. But we do want to be able to set this up as a proportion and solve it. So we're going to compare our inches to our miles. So we have 1 inch for 20 miles. Now we know here we have 9 inches. So 9 is going to go in the numerator. We don't know the miles. That's our denominator. Okay, and we don't like it when that question mark is in the denominator, so we're going to flip. So we'll have 20 over 1 equals 9. Oh, question mark over 9. and we solve. So to undo dividing by 9, we just multiply by 9. In this case, we could have just done 20 times 9 because it was to a 1 ratio. However, if we have a different number, like it's like 3 inches to 26 miles, things like that, we might want to write that out. So if you would like to use your calculator, 20 over 1 times 9, and we get 180. So that road is 180 miles long. All right, and that's it.